By pioneering knowledge-driven agentic AI, Vitria has solved the black box problem of agentic AI, replacing a reactive and probabilistic approach with a system of understanding layer that ensures agentic AI sees a connected system from infrastructure to network to services to revenue. Today's service delivery networks are complex and often generate hundreds of thousands of fault and degradation alerts daily. And amongst all this noise, it is not always immediately obvious to either a human or AI agent that two separate faults are related. The AIOps system is continuously monitoring the service delivery network, and through the real-time ingestion of melt data, AI/ML-based detection, and knowledge graph-based correlation, it creates a single smart incident containing all signals related to causes and effects of the problem that drives the triage, root cause analysis, and agentic AI-based remediation workflows. At the heart of VIA AIOps is structured knowledge in the form of a self-evolving knowledge plane, which is used by the platform to improve reasoning capabilities, explainability, and accuracy of its AI agents. The structured knowledge, represented as knowledge graphs, is formally expressed in RDF and is both machine and human readable, an essential property for better human and AI collaboration. The self-evolving knowledge plane is a shareable accumulation of the knowledge critical to correlating, diagnosing, and remediating outages and incidents occurring in large service delivery networks. As can be seen from this example, knowledge captured and maintained includes topologies across network layers, infrastructure layers, and service layers, as well as topological classes, classification taxonomies, patterns, and constraints among network elements and element types. Learned and inferred dependencies among elements and types, including failure patterns, and dependencies inferred from telemetry data, represented here as dotted blue lines. Diagnostic knowledge, including key symptoms mined from historical tickets and remediation data. And finally, actionable knowledge, including determination of the root causes and the likely fix for issues, which powers the knowledge-driven agentic AI. Through advanced semantic analysis, entities, relationships, contexts, and workflows are modeled to build dynamic ontologies with human in the loop that power knowledge-driven agentic AI. By tapping into these ontologies, related semantic definitions, and the stored contextual data, AI prediction quality and overall effectiveness is significantly improved. In this example, the self-evolving knowledge plane's key benefits include: firstly, determination that the node has become completely isolated from its neighbors and has lost connectivity with the network is only possible through learning the topological relationships. Secondly, significant improvements in the accuracy and relevance of AI predictions for root cause analysis and next best action are achieved. Thirdly, enablement of intent-driven reasoning with automated guardrails to enable proactive and trustworthy decision-making. Finally, knowledge learned by one AI agent can be shared with other AI agents, multiplying the benefits. By delivering verifiable gains in incident correlation, root cause analysis, and automated remediation via AIOps, with its knowledge-driven agentic AI and self-evolving knowledge plane, advances the state-of-the-art in AIOps towards self-healing, bridging the trust gap while enabling a true understanding of the end-to-end service delivery chain.